last week. That was one of our most registered and attended webinars we've had so far. So we're really excited, really pumped today to be talking about the architecture. I'm just going to go over really quickly a 5-minute recap on what we talked about last week, an overview of Couchbase Lite and Sync Gateway. So for those of you who attended last week, just hold on for 5 minutes and we'll get started on architecture. So the first thing I want to talk about is our mobile strategy, which is JSON Anywhere. This idea that that you can consume and create and consume data from anywhere and at any time. JSON has become a really popular way to represent data as it becomes richer and much more unstructured. So we've come up with the strategy JSON Anywhere to have JSON on the device, on the wire, and in the cloud. With JSON on device, we have Couchbase Lite, and on the wire, we have Couchbase Sync Gateway to connect with Couchbase Server, which is our JSON on the cloud component. Sorry. With Couchbase Lite is the only NoSQL database for mobile devices and uses JSON. We've made it to be ultra lightweight, to be secure with a light footprint, and it has currently native support for iOS and Android using Objective-C APIs and Java APIs respectively. And we also have REST APIs for HTML5 developers who are looking for a hybrid approach to mobile applications. Our APIs include full document management, including read writing, as well as indexing, querying, and we also have attachment support for all your blob data such as pictures, videos, PDFs, whatever you can name. And in addition to that, when we're talking about mobile applications, a strong requirement for a lot of these is to be able to do syncing. And to ensure that you get the latest and greatest version of your document while syncing and collaborating with other users, we have powerful conflict resolution and various different parts of the Couchbase mobile solution, including on-device, on Couchbase Lite, and in Sync Gateway. Speaking of Sync Gateway, Couchbase Sync Gateway is our easy, reliable data sync to the cloud. We've made it super easy to use and super easy to administer using REST APIs. And when we started out with this project, we knew that sync was a really hard problem to solve, an extremely complicated problem to solve. So we designed our sync to be really easy to use with just a single page of code that's already templated out that you can just easily custom to your needs. And that's really easy to scale out once you have, as your users or your throughput needs grow. The last piece of the JSON Anywhere strategy is Couchbase Server, which is our industry-leading NoSQL document-oriented database that can be deployed on-premise or in the cloud. On-premise is really popular with our customers who are looking for a private cloud approach, for looking to having a more on-hands cluster management approach. And we also have it available today on Amazon Marketplace for single-click deployment to AWS. We also have cloud services today, including Couchbase Cloud, which is a sandbox database service that we've started to get folks ramped up on Couchbase Sync Gateway and Couchbase Server. But we also like to recommend Couchbase, a company that we're partnered with that delivers production quality Couchbase Server as a service. And the last piece that I want to just highlight about Couchbase Lite is our partnerships that we created to support nearly 2 million developers in a variety of spaces, including with PhoneGap, Xamarin, and Accelerator. So with that, I'll hand it over to Chris, who will be diving into a deeper look into Couchbase Lite and Sync Gateway architecture.
Hi, everyone. So yeah, thanks for joining to learn more about Couchbase Lite and Sync Gateway. The thing I want to take you through first is kind of an overall architecture and how does the data flow, starting from the client, and then we'll talk about how it flows via Sync Gateway and Couchbase Server and back out to other clients. And so by going through the sort of day in the life of the document, hopefully that'll give you a good understanding about what's going on in your deployment of Couchbase Lite. So to start off with, and this is, we'll start with an overview and then we'll get deeper. We have Couchbase Server as the storage tier for, a mobile Couchbase deployment. And Couchbase Server has been used, for years by a whole bunch of really big deployments. And about half of our existing customer and user base deploys their own Couchbase server, and the other half tend to run it on cloud services like Amazon, etc. So that's a proven storage tier, and the reason why people use it is because it's got the horizontal scalability, so that you can throw more, more nodes at it as your requirements and as your traffic dictate. And so we wanted to maintain that ability to scale on demand, as we built out the rest of the capability set for Couchbase and mobile. So the Sync Gateway is a shared nothing tier that essentially sits between Couchbase Server for storage and mobile devices, that are out in the world. So from a scalability and architecture standpoint, you can almost think of Sync Gateway as occupying the application tier, in that you can have, however many instances of Sync Gateway running. They're all stateless, and so they can be, restarted or moved around kind of at will without impacting the quality of service, as long as you got enough of them for the traffic you're trying to drive. So these Sync Gateways are these stateless processes that connect to an event feed, which we'll get into more detail here in a second, from Couchbase Server, and then provide those events on document change out to mobile devices. So, as Jessica said, the platforms we support right now are iOS and Android, with hooks for various development kind of runtimes inside of those operating systems. So typically, it's going to be a native application like Objective-C on iOS or Java on Android, but we're also open to people using these, especially multi-platform development toolkits. So I want to show just a quick demo. You may have seen it before if you've been to other of our webinars. I'm not going to go into the depth that I've gone in the past, but just to set the stage to understand the kind of apps that we're talking about. And the features to look at in this demo, and then we'll come back and talk about how these documents flow through the system, through the architecture. But the demo is really designed to show off CRUD operations on the embedded database on the device. So I'll launch this demo app, and I'll do some data interactions with it that are all purely local. And then I'll log into the cloud via Facebook in this case. And I'm logging into Couchbase Cloud, where it'll pull down all my existing data from, me having used this app in the past. You'll also be able to see how when I make changes, they, immediately show up in the user interface. And, one of the important things about that is that the changes that happen in one of these distributed mobile applications, they're, as often as not, it's some other user who did something on their device, and you need to reflect that data on your device. So let's go pull that demo up and see how it works. So I'm going to launch it from Xcode. This demo is actually all written using our PhoneGap toolkit, and it's not real important for this specific talk. I'll show a little bit about how PhoneGap works, but you can imagine it being written in any of the cross-platform frameworks we support. And so I can have, I can have a to task list. So let's say for the, for the secret product release, right? We want to do some things. So we're going to have, press briefings, and we have to actually ship the product. So you may have this kind of task list, and inside of the task list, you are able to check off items and interact with all this. And all this is happening locally, so even if I'm in airplane mode, the latency is always the same. It's always more or less instantaneous. So what I can do now
Chris, sorry to
is
interrupt. I think
log in via Facebook.
Chris, sorry, there is some lag on the demo on GoToWebinar, so maybe you can relaunch it.
Okay, are you seeing the screen? Well, here, give me 1 second. Are you seeing my Xcode screen?
Yeah.
Or
we see the.
So what I'm doing now is logging in with Facebook, and this can take some time also, I think. So I've connected my instance of To-Do Lite to the cloud, and remote changes should be coming in here. And it looks like my internet is working kind of slowly. But the idea is that my updates that I've made in the cloud can be available on this device.
Okay,
so,
now we see the Facebook login.
Let's see. We can come back and look at that in a second. I may have overwhelmed my internet connection. So I hope folks can still hear me. I wanted to give a sense of it. So now we're going to go back into the slides and look at a day in the life of the document. So are you able to hear me now?
Yes, we see the slide. I think the demo was also working, but it just took some time to load.
Okay. So so in that demo, we saw these updates happening on the mobile device, and then we saw well, after I logged in, and it may just be my internet was overwhelmed, but the data that I just created was being pushed up to the cloud, and we can go in and sort of see how that data flow goes. So we've got the mobile device, and after some work has been done locally on the mobile device and it's able to connect to the network, so you may or may not have been offline. If you're online, this will happen right away. If you were offline, then as soon as you go back online, it pushes data back up to the Sync Gateway. And this is all via the HTTP protocol. So we use HTTP because it's supported by all the mobile carriers and works well. And if the network doesn't support the web, then they're going to be dealing with a whole bunch of bug requests. So we don't want to be special from a traffic standpoint, and using the HTTP standard makes us work over the wide area mobile networks reliably. So now that HTTP post has hit the Sync Gateway with our JSON documents, and maybe it's like we made 10 edits while we were disconnected, so it's those 10 edits that are being pushed up. And the Sync Gateway is going to process where the JavaScript sync function is the user code that you actually write that programs the Sync Gateway to be your application, and not just a generic sync mechanism. So by the end of this talk, I hope to have given you enough information on this JavaScript sync function so that you can see what you could do with it and if you could build your application with it. And so depending on the results of the sync function, but let's say this data, everything gets written, and these documents may be written to a few different channels. So the original JSON data, as well as some of the metadata that's generated by the sync function here, are written to Couchbase server. And since that storage is a cluster and redundant and high performance, we actually use Couchbase server as the basis of communication among all the shared nothing Sync Gateway HTTP server nodes. So Couchbase server has a feed called tap feed and a protocol called the Universal Protocol for Replication. And together those allow us to have the Sync Gateway know in real time what documents have changed in Couchbase server, and then again to broadcast those changes back out to any connected clients. So that's kind of, in a nutshell, the overview of the data flow. We're going to look at that again in a couple minutes. So this first time through is really just to get you familiar with it. So again, just before we move on, while I've got this picture on the screen, those green arrows that we have now, any communication between the mobile devices and the Sync Gateway, that's all over HTTP. And then the communication between the Sync Gateway and Couchbase Server is all using the Couchbase Server protocols. So Couchbase Server is, designed to run inside of a data center and to power applications. And so Sync Gateway is what adapts it to, connect directly to clients and handles, access control and authentication and authorization. So we'll get into the details of how the Sync Gateway controls access to, to Couchbase Server in the second half. But now let's actually look at the client and, look at what it means to have an embedded database. So it's easy for us to spend a lot of time talking about Sync when we're talking about Couchbase Lite because it's, sort of the standout feature that you haven't seen much of in the mobile database world in the past. But from a developer standpoint, it almost makes more sense to think of it as an embedded database. You saw how the application, the demo that I was running there, was able to, work fine with its local collection of data, even though the internet connection, wasn't working properly. And so there are also, a ton of applications that may not need synchronization, but may want to have a JSON document model on the device. So in that case, it makes sense to have an embedded database, even if you don't need it to do any of the synchronization for you. So on the inside of Couchbase Lite, this is what it looks like. The storage module here is essentially a pluggable storage where we store JSON and indexes. So for each document, we're going to accumulate the different revisions over time, and there's a compaction command that you can run to clean out the local storage. But that gives us MVCC and the ability for you to write, things like validations that compare an old and a new version of the document. The indexes are built using the same model as Couchbase Server. So if you've used Couchbase Server's MapReduce and written a JavaScript function that creates an index based on a particular field in the document, you can do that here. The one difference is we're going to encourage that you use the native programming language for the platform. So, while we have JavaScript support as optional plugin, really most of your apps are going to be best off most of the time using native views instead of JavaScript views, just because they're going to, compile to a, small native code that can execute and take up almost, none of your actual application cycles. So writing your JavaScript or writing your MapReduce in Objective-C instead of JavaScript, if you're used to doing it on Couchbase Server, takes a little bit of getting used to. But I'll show an example of this in a few slides, and the way that it actually comes out as an Objective-C iPhone programmer, to me, starts to feel pretty intuitive. Like you don't have to switch languages or anything, and you're just embedding this little index definition in your code. So I'll show that in a minute. Then there's the query engine, which is also similar to Couchbase Server. So the way that the whole overall query model works is that you define these indexes and then you extract ranges out of them. So we'll see a little bit of that in the query example that I show as well. And then, of course, the sync engine, which runs on a background thread so that it doesn't impact your UI performance. So the sync engine can connect to multiple other remote sources. They can be Sync Gateway in the cloud, or they could be other Couchbase Lite instances, on the local area network. And it makes sure that all the changes that happen remotely are played into the local storage so that they're available to local queries. And then there's the application API, where what we've done here is because we don't think of Couchbase Lite as being a as multi-platform as being really like at the top of the list, but we do think it's pretty cool that you can have the same data across all these platforms. And so that means that we've done the work to make sure that our application API, as you interact with, like say Java and iOS, and let's say you're doing some Xamarin and some PhoneGap, you shouldn't run into a whole lot of big differences. The idea is to have an API that gives you the same access to your data across all the platforms. And so here's an iOS example. This is some Objective-C code, and I'm not going to go through every single line here, but I've circled a few lines. So the gist of this code is that it generates the query object, which populates that view that's on the screen there. So in the view, it's a to-do list, similar to the app that I just showed, but this one is the native implementation. And it's got items on there. You can check the items off, and the important thing is that the view only shows the items for this list, and it has them sorted by the date they were added. So what we'll do here is go through these lines of code. The first one that I've got circled is just pulling the view object out of the database. And so in iOS, this is just like a native object that represents the ability to query this database for this tasks by date view. And if this is the first time we've ever pulled this object, then it's not going to have a map block. So this is the part where I think it's kind of intuitive as an iOS programmer, because you just get to drop this definition of the index in the first time you need it. So if there isn't a map block, well, then the map block is going to be this code here that I've circled the important part of it, which is to emit the list ID and the date as a key. And so this emit function takes two arguments, and in this case, the first argument is that array, so it's a complex key, and the second argument is the document body itself. So we're using the document to populate this list, and we're sorting the list. We're sorting the index by the list, and then within each list, with that complex key, we're sorting by date. So if you look in that second circle, it's emit list ID comma date and the document, and so that complex key is what's powering this view over on the left side here. So the last thing that we'll do is, because this tasks query function that we're looking at is scoped to a specific to-do list, we'll go ahead and tag it with my list ID. So that's that last green circle that goes and sets up the query object and returns it. So query that's returned there, you can actually call another method that I'm not showing on the screen to turn it into a live query. And when you do that, that means that you're done. Once you set up that live query, it's automatically going to refresh the table view for you as the database changes underneath. So if somebody else on another device adds something to your to-do list, it'll show up locally. So I think that is the I think that's as deep into Objective-C as we're going to get. We didn't want to do too much application code, but I want to give you a sense for what it's like to program against this. So here we are. Let's look inside of the application process. So it's running inside of an iOS, operating system process, or Android process, running on the Dalvik VM. And your basic app is going to have all in the same memory space, Couchbase Lite embedded into the same code as your native application logic, and then we're going to use whatever the native storage is on the device. So it's just a regular embedded database, and you're calling to it directly with APIs like we saw in that iOS example a second ago. In the demo app that I showed, where it was running inside of a web view, it's a little bit different. We have an optional REST connector that we can add that gives you the ability to connect directly to the database via XHR and AJAX, so that you can have existing code that knows how to use, say, jQuery to make JSON requests against a remote server and instead point that to Couchbase Lite on the device. And this makes for a pretty intuitive way to program in PhoneGap and potentially get a similar APIs, in the browser, so that you can offer the same application, on the device as on the web. So with one of the REST libraries that I like to use, the database interactions are going to boil down to something simple like this in the PhoneGap context. It's we're just going to do an HTTP GET against the URL that's formed by adding the document ID to the database URL. And so this driver here is handling all that. We're just throwing the ID of this document that we want to toggle the checkbox on at the REST GET method, and then we're doing some native data manipulations in JavaScript, updating that timestamp, and then doing a REST put back at the same ID. And so it's really just XHR jQuery style calls under the hood. So this is going to be sort of universally available runtime, even on applications where maybe AppCelerator or Xamarin aren't available yet. There's a web view available most anywhere, and the REST adapter that we have for it isn't just tied to PhoneGap. PhoneGap is kind of how we put it out there as an example, but you can use it from inside of other frameworks as well. So the last thing to note about this code is that the callback on the very last line there, the function, is empty. Why would you have this empty function? Traditionally, in kind of interactive UI programming, you would have that callback, which is going to run when your checked off document is successfully saved. Then you would update the UI to reflect that. In this case, we're not doing anything. And the reason why is because, and I'm not going to go through the code for this, but similar to in that iOS example we saw, in the PhoneGap context with the REST adapter, you can also do live queries and have the UI automatically update whenever some underlying data changes. So once you have live query, then you don't have to worry about following all of your data changes up directly with their own UI updates. You can let your live query handle that, and that means that remote changes are going to be on the same footing as local changes. So that's kind of to wrap it up. For the client side, there's a whole bunch of richness and sort of developer features on the embedded database that are really just specifically local embedded database features. And now let's turn our attention to the Sync Gateway. So we'll go back through that same data flow again, but we'll think about the case where the data that is synced doesn't go to everybody. So we're going to push a document up from one of these clients, and we're going to run that sync function. Instead of writing it to, say, like a globally readable channel, it's going to write it to to-do lists, let's say, that's only shared between some of the users, not all of the users. And so we'll actually drill into this sync function code in a minute here, but I just want to make it clear that that's the place in this architecture where you, as the application developer, decide who gets to see what and who gets to modify what. So the sync function has this whole API that we'll get into, but in the gist of this case, that write that we saw the client do, it's been tagged with some channels, and maybe depending on, and we'll see how you can do this in a second, and maybe it's also modified the access control list for some channels. So in this case, the change here is going to be stored just like we saw before, but with a different set of metadata, a different set of channels associated with that document. And then it's also going to get broadcast on the tap upper feed again, so that all the sync gateways in the cluster know about it. And then we see here we're going to use that same protocol to put the HTTP changes back on the wire as we did before. The difference being that we're leaving one of the clients out. And so the selective sync, what it really boils down to is that you can have, some people see some data and some people see other data, and it's up to your application who sees what. So the approach we use for that is called channels, and here's like a sort of introduction to channels. So I'll animate it a couple of different ways, and hopefully it gets clear. So we have document 1, and it belongs to channel A. And we have document 2, and it belongs to channels A and B. So if we have a user who is listening to channels A and B, they're going to get both those documents. And if we have another user who's just listening to channel B, they're not going to get everything, right? They're just going to get some of the documents. Or in this kind of simplistic stop motion animation, the data is going to flow in to the sync gateway, where your sync function is going to make some distinction between different kinds of data and route it to the correct clients. So now we can talk about the sync gateway and hopefully get into some of the sync function stuff. So the sync gateway, again on that first diagram we saw, it's the middle tier. So it uses Couchbase Server for storage, and it provides data to mobile devices over the HTTP connection. And I wanted to push talking about authentication back a little bit. So we will talk about it. So the first thing that happens when a request comes in is it's authenticated. And for now, let's just hand wave and say, it needs to do validation. That means that it can decide, some user rooted their Android phone and they went in and changed all their JSON documents, and now those are coming inbound. What are you going to do? So this sync function is running in the cloud, and it knows who is logged in. And so you can do things like require that the document that's being modified have a field on it that's the same, as the user's name. So you could say, oh, the old version of the document's owner is the current user. And if it's not the case, then the sync function will throw an error, and that write will be rejected. And so those invalid documents will never leave, the phone where the joker rooted it and messed around with the JSON data. The other responsibility, and the big one that we just looked at all those animations for, is routing. And so this is where you take a document and you decide what channels it belongs to. In the simplest case, you could just hard code the list of channels on the document and have one channel or an array of channels. In a more complex case, you're gonna end up generating the channel ID in the sync function somehow, from the document, and we end up doing that in the example that I'll show here. We go into detail and sort of create some channel names in the function. The last responsibility, and this was one that we added a little bit later in the development cycle, as we were getting a feel for these APIs. So if you could do these validations and route data to channels, the only thing missing is who can see which channels. And so there is a mechanism to allow you to manually grab a user, jChris at Couchbase, and put the access, give them access to a channel or a set of channels. And that's great as an administrator, or if you want to write software that's always interacting with the administrative APIs on Sync Gateway. but it doesn't really fit the mold of everything else we were doing, where the document flows through the sync function and stuff just happens. And so we wanted the sync function to cover, all your runtime needs for the real-time interactive application without you having to stand up some other process to at least get the basic work done. So what was missing was the ability to do dynamic access control. So we added that to the sync function with this access call. And so what happens in practice is sometimes a document may come through that specifically defines and provisions a new channel. So in the case of the to-do list, we may make a new to-do list and invite some users to it. And so what that ends up doing is generating the channel for that to-do list and then granting those users access to that channel. So we'll look at that again in a second. There's also, and I could go into a whole bunch of detail about this, but we probably don't have time today. I'll talk about it a little bit some more later. But in general, one of the problems with a distributed system is you can have two people who are making changes to the same data item basically at the same time. Maybe they're both disconnected. Maybe just one of them is disconnected. And when they reconnect, your data management system has to do something about the fact that this document exists in more than one state. And so we use a revision tree approach to managing this, and I'll talk more about that in a little bit, but the gist of it is that we don't ever throw any data away, and we give you the opportunity to defer making merge or conflict resolution work happen. So you don't have to do it when you first see the conflict. You can say, oh, this conflict is better to resolve in the UI, or this conflict is better to resolve from a script on the back end, and we allow you to do what makes sense for your application on a per document basis. And then the last stage of the sync gateway is when it's actually validated the app through the sync function and done whatever conflict management it needs to do. And then it writes all that to Couchbase, which can scale independently and allows Sync Gateway to be totally stateless. So now to drill back into that sync function. And hopefully we'll spend a few minutes on this, and feel free to ask questions about this stuff. I should have some time at the end for questions. So, as I said, we were working on this API for a long time, and the goal was to make it so that your entire backend, at least as far as the data that syncs is concerned, so from the standpoint of a greenfield app where the data is generated on mobile devices, you really should be able to do your whole backend in one page of code for the 80% case, and then potentially add on additional stuff for things like push notifications or sending an email when a new user signs up. But you're just real basic application flow for 80% of applications. The goal was to get that to be something that you could manage from this sync function. So this is the sync function for that demo app, the to-do list manager, and it does the access control and the routing of documents to channels, and it does some update validation. So we'll look at all of those, and we'll kind of go through these green circles I have here in order. So the first thing I've got circled is what we do when we see an actual task document. And in this case, it's real simple. We just make sure that it has a list ID. And if it doesn't have a list ID, then we throw a warning, we throw an error message. Otherwise, we put it on the channel that goes with that list ID. And so that's what that call to channel parentheses list is there at the bottom of that first, task if expression. Then we do else if the document's type is a list, and now we're in this second branch of the conditional. And these documents are more interesting. The list documents are the ones that actually sort of define a task list, and say who the owner is and who the owner is sharing it with. So in this case, we want to make sure and enforce some additional rules. So where I've circled there, require user, what we're making sure is that if this isn't the first time we've seen this task list, that the owner matches the person who's doing the update. And essentially that says you can't just go change somebody else's list. You can't go add new member to somebody else's list. It has to be your list. So that's what that second green circle is. And then on the third green circle, this is where we grant access to those members so they can read from the list. So if I was to share a list with some people from work, what would happen is it would create their user IDs as an array on that list document. So the document's type would be list, and then the document's members would be the email addresses of people from work. And so when that happens, this function then runs the access call in this third green circle here and grants those members access to the channel associated with this list. So now they have the ability to see and interact with the task documents on that list. The last third of the function here is about the profile documents, and I won't really go into too much detail except for to say that these profile documents are the ones that you browse when you're deciding who to share a list with. So, right now it's set up so that you see every user of the app, but in a more real-world situation, you would have this be, so every user would see all their friends. So I want to talk a little bit about that custom authentication. And so here is the picture we saw a little bit earlier, but with a little bit more detail. So when synchronization requests come in via that REST API, they're going to go into the authentication module first. And in most of the examples, and kind of the easy path is to use the built-in Facebook or Mozilla Persona authenticators, or the built-in OAuth, the OAuth 2. But if you want to do some sort of external authentication service, then that's when you can reach outside of the Sync Gateway process and have another server that sets up a session that Couchbase Lite uses. So how that custom authentication actually works. So in this case, you've got Couchbase Lite embedded in your mobile application, and your mobile application can make a request. Actually, this would be your code that you wrote in your mobile application, and it makes a request to your server that you probably already have, right? So if you already have custom authentication set up, you've probably already got code on your iOS app that can talk to your Rails server to log in. So basically, you just make that connection that you've already got working, and then you have your back-end application server, like your Rails app or whatever, go and do its authentication flow to figure out who you are. Maybe it's looking you up in a pre-existing MySQL table. It doesn't really matter. So once that process, knows who you are, then it can ask Sync Gateway for a session and say, okay, I've got user jchris here. Can I have a session? And I need it to be valid for 2 hours or whatever. And so Sync Gateway will say, sure, here's a session for jchris. The session key is blah. And so now that authentication REST endpoint in your custom app server, in your Rails app or whatever, can take that session ID, and the simplest thing is just to set it as a cookie on the response, but you could also send it more explicitly in the response payload, and have code back on the client tell Couchbase Lite about it. Either way, so let's pretend you set it as a cookie, In that case, it'll automatically get picked up, and assuming Sync Gateway is running on the same domain as your app server, it'll be used for requests to that Sync Gateway, or you can set it manually. Either way, it's just a matter of which code path you're going through. But the idea is that when the mobile device connects to Sync Gateway, it uses the session key that your app server has associated with the user account. So in this way, you can authenticate as whatever user. So let's see, I think this may be the last topic I really wanted to talk about, and this is the data structures that we use for conflict detection and management. And I have a big animation of this that I can go through for like 10 or 15 minutes, but I'm not going to do that. I'll just, let's see if I can, the gist of it is that we hang on to the metadata history of the document, and then that allows us to throw away the document bodies for documents that have been overwritten. Right? So if we know for any given update what its parent update is, then when those are merged later via sync, we know that we no longer need to hang on to that parent update, and it allows us to compact and save space. But it also gives us a structured approach so that if we have two updates that have a common parent, or maybe they don't, maybe they just have a common ancestor, it allows us to understand what the relationship is between those. And then you can use that information programmatically to do some various automatic data merging schemes. And so I obviously don't have time to go in depth into the conflict detection stuff, but the key takeaway is to understand that we're never going to throw away your data just because two people changed something at the same time. And maybe the other takeaway is that even though we have all this super featureful ability to interact with the conflict in a really well specified way, most of the apps I see over the years, and by most, maybe like 80-90% of them, have been completely naive about conflicts, like where all they do is make sure that their documents are fine-grained enough, and then the way that the conflict algorithm works is you tend to read your own rights, and so that tends to have the system quiesce in a usable state, even if you're being naive about conflicts. If you want to get in and start merging things intelligently, there's a whole bunch of things you can do. So maybe we'll have another webinar about that, in the future someday. So the last thing to think about is, hey, maybe this sounds like fun. You want to get started. So what are the resources? The best one, tell your friends, is mobile.couchbase.com. And so that's a redirect link, and it's going to redirect to wherever the best spot is for downloads and whatever as we go forward. So you can always just remember mobile.couchbase.com. You can check out these slides later for some of the links to some of the example code. But I think actually that stuff shows up even better on mobile.couchbase.com than if you just go there, that should have everything you need. And then the other thing that's cool is Couchbase Cloud, and this is an experimental developer sandbox. It's really, it's the idea is that you can get up and running with Sync Gateway without having to invest in a download or setting up something on Amazon. Basically, it's more fun to develop Couchbase Lite against a internet accessible copy of Sync Gateway. You could just run it on your laptop and develop in the simulator, but as soon as you want to use real mobile devices or show it to your friends, it's way better to have Couchbase Cloud or to deploy your own Sync Gateway in the cloud. So try out Couchbase Cloud. Right now, it's not for production use. It's really just for development and kicking the tires. But as Jessica mentioned earlier, there's also Couchbase, and we see, if what you're looking for is cloud-managed Couchbase, and Sync Gateway, that's I think you'll be able to get it. So let's take a look through the questions. We have a few minutes left. Thank you.
Thank you, Chris. Great presentation. So we have a lot of questions, and we will try to cover as many as possible in these last few minutes. So first question from Paul. How does indexing work in Couchbase Lite? Is it the same of Couchbase Server?
Yeah, it basically is the same as Couchbase Server. The big difference is that the reduces are not super magical fast in the way they are in Couchbase Server. The reduces aren't pre-cached in the intermediate storage nodes the way that we do, but for typical use cases, it hasn't been a problem.
Thank you. Another question from Mel. So in a cross data center deployment, can my Sync Gateway connect to either data center? How are the mobile connection load balanced?
That's a real good question. We don't officially support XDCR yet right now. I mean, you could bring up Sync Gateway read-only in your second data center, I think, without doing any harm. But yeah, the short answer is we needed to do our XDCR homework for you. I think nothing really scares me about that, but yeah, I can't really tell you to go out and do it just yet.
Great, thank you. So a question from Michael. Is there a limit on channels? For example, on a large-scale site like a social network with millions of users?
There's no real limit on the number of channels in a system. So each channel is going to have a document in Couchbase Server, and so you'll end up with lots of small documents if you have really high cardinality of channels. But where you're actually going to start to get a load multiplier is where you have documents that belong to lots of channels. So if you have a system where each document belongs to like 20 channels, that might be a problem. If each document belongs to one channel and all the channels are different, that's probably okay. But the case that we're thinking of is each document belongs to like 1, 2, maybe a handful of channels, and there's roughly the amount of channels as users, give or take an order of magnitude.
Thank you, Chris. Another question. Can you transfer binary data in Couchbase Lite, and at what performance?
Yes. So we have binary attachments, and that's because we know that for social media apps, things like photographs are really important, or user, avatars, etc. Performance-wise, it should be comparable to other things that's going to be happening on the mobile device. So we use file system storage, for instance, on the device for these attachments. There's some enhancements that we plan to make. Those are mostly on the server side, about like allowing, for instance, right now all attachments are stored with all the rest of the data in Couchbase Server, and it would make a lot of sense for us to give you the ability to put them, somewhere that's specifically tuned for binary blobs, for large attachments. So I hope that answers the question.
Great. We have a lot of questions coming about conflict resolution. Since we don't have the time for a deep answer, can you just maybe give a little more information and point the attendees to a resource that they can access later?
Yeah, so I gave this talk at Strange Loop recently, and I'm pretty sure it was on video. So if you find the Strange Loop videos, or OSCON, although I'm not sure if that was on video, I go through all the conflict resolution stuff. Maybe to answer some of the questions that I see in here. So the conflict can be resolved on any peer. That means that you can have UI code and a client resolve a conflict, or you can have script, that's listening to these event feeds on the back end resolve conflicts. And it's just going to depend on your data which one is more appropriate. About the only big gotcha to worry about is if you have scripts that are fighting over how to resolve the conflict. If they both resolve the conflict the same way at the same time, that's not a problem. But if they disagree about how to resolve the conflict, then you can get a ping pong that builds up more conflicts than it resolves. So maybe that helps that question.
Thank you, Chris. And again, since this is a very significant topic on Couchbase Lite, we will follow up with all the registrants tomorrow with some more resources about conflict resolution in Couchbase Lite. So we have time for one last question, and is what is the impact of Couchbase Lite in terms of both battery performance on the device and data transfer?
Sure. So we try real hard to make sure it's lightweight. So it's about 0.5 megabyte of additional download payload into your application, as a library, and hopefully, almost has no impact on the launch time of the application. So those we see as being really key. As far as the network performance, it's there's going to be some associated overhead with some of the sync metadata. So for any given application, you could always write something that was more tightly bound to what exactly the data you need to do is, but you'll end up writing your own sync system. And it's pretty decent. The big gambit we make for performance is that if you know in advance what data the user is going to want on their device, then they've already got it. And so, we try not to have huge multiplier effects in terms of what we do on the wire. And so we use compression and do sensible things around that. As far as battery life, that is real important for us too. It's gotten to be some of the, so we stay as native as possible is kind of how we do the battery life thing. And then in the future we're working on enhancements for kind of smarter scheduling about when we use the network. And compared to our earlier prototypes, it's pretty decent. I mean, it's really also a lot up to you. So if you do really aggressive synchronization, it's going to keep the network and the radio running as much as possible. But if you do sort of more of background synchronization, then it's obviously going to use less network. So yeah, hopefully that helps. The range of best practices in the battery life stuff is really wide. So we know there's always going to be stuff we can't do. So we try to give you as a developer the hooks you need to push it a little bit farther. And the community were really open to suggestions about what we could do, where we could put those hooks, or what we could do by default. So thank you.
Perfect. Thank you, Chris. So that's all the time we have for today. I just want to remind everyone that next Tuesday we will have a specific webinar for developing with Couchbase Lite iOS at 10 a.m. Pacific, and the following week we will have developing with Couchbase Lite Android for those of you who are interested. So again, this is all the time we have, and I want to invite everyone to download Couchbase Lite at mobile.couchbase.com. Thank you everyone for joining us today, and I hope to see you all next Tuesday.